Hey there, C# friends. My name's Matthew. I'm the C# artisan, and this is the 6th video in my series on nullable reference types. And today, I want to talk about migrating a legacy codebase to use nullable reference types. Now, if you're starting a new Visual Studio project, the feature will be enabled by default, and writing the code is pretty straightforward. Mostly, you follow the warnings. But if you have a legacy codebase and are thinking of converting it to use nullable reference types, well, that's a bit more complicated. And the first question you want to ask is, should you even do it? Choosing to leave your existing code alone is a totally legitimate choice in many situations. Your code is stable and tested, it's been running for years, and it's not prone to null reference exceptions. So why bother? But there are some cases where you do need to bother. Let's say that your code has been published as a NuGet package. It's out in the public domain. Or maybe you've written a class library or a framework that's used by other groups, other programmers in your organization. In these cases, you really need to assume that those other programmers are writing new code, which has nullable reference types enabled, and they're going to expect your code to be nullable reference type savvy. They're going to expect it to be properly annotated and to behave in predictable ways. So in that situation, you're kind of on the hook, and you do need to update your code. In this little video, I just want to talk about a few techniques you can use to tame the complexity a bit and get a good result. To talk about converting a legacy codebase, I've created a little class here called person, which just has a few properties and some functions as a way to illustrate some of the issues you might have. So one approach you might take is what I would call the bombs away approach, where you go to the project and you just enable nullable reference types. And now, when you build this, you're going to start getting those compiler warnings. And here you can see we've got 3 of them. And we've got some highlighting in the code as well. So that works, but here's the problem. If your code base is large, and the use case for this is a large legacy code base, well, you're just going to be flooded with warnings. And then as you start addressing certain things, new warnings will pop up. For example, if I annotate person as nullable to clear that warning, another one pops up down here because now I've got a possible null dereferencing of a null variable. So it can just get a little overwhelming and hard to organize and hard to manage, and maybe you start rushing and it just doesn't come out very well. So what can you do? So let's turn this back off. We'll set it to disable. Whoops. And we have the ability to essentially turn on the feature file by file by using some pragmas. So I've copied them to a notepad document, and now let me just paste them in here in the file. So this first pragma is nullable enable annotations. So what that does is it allows you to start adding annotations without receiving a compiler warning. If you don't have that there and you add an annotation, what's going to happen when you build is you're going to get this the annotation for nullable reference types should only be used in code within a nullable annotations context. That's CS 8632. So we turn this on, which allows us to annotate the code. And then we turn on our warnings, which starts enabling these. Without that, what you'll see is that we don't get the warnings. So putting these together has the effect of turning the feature on for one file. And then you can work your way through the file and start addressing these, for example, by creating your default value there for the name, or by figuring out that your default here should be string.empty rather than null. However you're going to address these warnings, you can just go ahead and do it for this one file. But I want to suggest what I think is an even better approach. And here's the problem with this approach. If you look at some of these functions, it may be a little hard to tell from the warnings or lack of warnings whether they're safe or not. For example, this warning here doesn't appear until I annotate the class. So when you just turn the setting on, when you just enable it, you may or may not get a really good sense of how much work there really is. So the approach that I like could be called annotations first. And the idea is you go through your code and you make careful decisions about the meaning of variables. You look at the syntax and the meaning of the code and you annotate first. And then once your code is properly annotated, you turn on the warnings and start addressing the real warnings that you're going to get. So the way to do this, one way is file by file. You can, for example, just enable annotations for a single file like that and go through and annotate. But you can also turn it on globally by going here and setting the project setting to annotations. That's basically like adding this pragma to every single file. So now I can take that out and I can annotate the file. So I can go through and I can say, okay, my name property, it's a string and it should never be null. We never want a person with a null name. So that one is correct. But parent, that's optional. So I better annotate that and just say that really is nullable. Moving on, I can look at this function, double a string, which takes a string and makes two copies of it. And what we can see here is that, first of all, the input does safely accept nulls. It has a null check. So what we would want to do is mark that and say, this will accept a null. No worries, it's now properly annotated. But much like the framework string.concat function, this thing will never, ever return a null. So we don't need to mark this one as null. In fact, for correct annotation, we want to leave it as just a string. So now this file has been annotated. We can build it. We're still not getting any compiler warnings. We've just gone through and made careful decisions about what is what's truly nullable, and what really should never be null. Now, when we turn on the warnings, either globally by turning them on for the whole project or just going file by file, now the useful warnings really pop up, and we can see that this name field should either be initialized or maybe we'll just say we'll mark it as required. That'd be a good way to do that. And then here we have this possibility that we are returning null. And so we just need to change that to string.empty. There's another way to do it, right? We've seen you don't have to use the ternary operator, but there's no need to rewrite this code. And here, well, we better dereference that. So now we can equality test, and if name matches to null, if that expression returns null, it'll be false. So the meaning of the function is unchanged. We just cleared the compiler warning. And this one doesn't need any change at all. It was already perfectly null safe. It just now has a better signature for people using it. And now when we build our solution, it works. So that's the approach. Start by turning annotations on. Go through your project and annotate. Then make another pass through, enable warnings for each file, clear those warnings in that file, and then when you're all done, you can go back and enable this globally, which is like setting both pragmas for every file. So that is my recommended approach for handling a legacy codebase. If you really do need to update it, and you may, try the annotations first approach. Hey there, C# friends. Are you enjoying these videos and finding them helpful? I hope so. And if you are, please go ahead and like the video on YouTube. If you haven't already, please subscribe to my channel and feel free to leave a comment. I would love to hear from you.